So now let's see our next example. So you need to solve uxx plus uyy equals to 0, and the given diagram is this. So this is your domain on which you need to solve the equation. So if you observe, then these are the 4 points which you need to calculate. So if you consider u1, so for u1 you have the formula for diagonal 5-point form. So if you consider u1, then by using diagonal form you can observe that you have 3 given points, that is 0, 0 and 0, but you don't know the value of u3, and similar goes in the case of all the rest of 3. So if you consider u2 here, then if you consider diagonal form, then 0, 0 and 0 is given, but you don't know the value of u4. Similarly for u3, you don't know the value of u1, and u4 you don't know the value of u2. For this, first of all, we need to assume certain values for them. That is, you need to assume that u1 of 0 to be something, then u2 of 0 to be some point, then similarly u3 of 0 and u4 of 0. So that are the initial values for u1, u2, u3 and u4. So easy way to remember is just see the values for the preceding. That means if you consider u3, u4, then just go above the line. So for this you have 1, 1 value. So for u4 and u3 you can assume the values as 1, 1. Similarly for u1 and u2, you can see the line below the below that u1 and u2, you'll get the numbers as 0, 0. So you can assume that u1, u2 will be 0 and u3, u4 to be 1. Now, as we have all these assumptions right now, you can use that assumptions in this equations. So u1 will be equal to, so u1 0 was the initial whatever we have assumed. Now u1 1 will be the answer first. So that's again approximation. So 1 upon 4 into again 0, 0, 0 and u3. So 0 plus 0 plus 0 and u3 was 1. So now after substituting this 1, you will get 0.25 as your answer. Similarly, you need to calculate for u21. For u21, you will have 1 upon 4 into 0 plus 0. So u21, so this is your u2. So if you go diagonally, then you have 0, 0, 0 and you have u4. So u4 value is again 1. So it is 1 divided by 4. Again its value is 0.25. Similarly for u31, you have the formula as 0.50, because for u31 you will have 1 plus 0 plus u1 which was 0, and then again this 1. So finally 1 plus 1 is 2. So you have 2 by 4 which is 0.5. Now for u41 you will have u41 again, if you go diagonal, then 1 plus 1 and then 0, and this is 0. So it is again 2 by 4 which is 0.5. Okay, so these are the approximations for the values of u1, u2, u3 and u4. Now we will use the Jacobi method and Gauss-Seidel method. So first you are going to use Jacobi method. Now first we will see our Jacobian method. So Jacobian method is nothing but you have calculated the first approximation of u1, u2, u3, u4. Now using this Jacobi method, you will calculate the next approximation, which will lead us to the most approximate value of u1, u2, u3 and u4. So for this, first you need to apply standard 5-point formula. So for this, using standard 5-point formula, you will get values of second approximations of u1, u2, u3 and u4. So this 2 indicates it is the second approximation, 1 indicates the first approximation, and 0 was the initial which we have assumed to be. So now u1 of 2 will be equal to 1 upon 4 into, now if you observe u1 of 4, so u1 is this, So u1, and you need to have the standard one. So you will have 0 plus 0 plus u2 1 and u4 1. So you'll just use the previous approximation values. So you'll have 0 plus 0 plus u2 1 plus u4 1, which was u2 1 was r 0.25 and u4 1 was 0.5. So after substituting the values, you will get 0.1875. So our first approximation was 0.25, and now we have just got a new approximation as 0.1875. So if you observe, then it is tending towards 0.1. So first we got 0.2 and now we are getting 0.18 something. So this is our next approximation. So similarly, approximation for u2. So second approximation for u2 will be equal to 1 upon 4. We'll use standard 5-point formula for all the for u1, u2 and u3 and u4. So for u2 you will have 0 plus 0 of u3 and u1. So for u3 and u1 you'll have the first approximation which we have calculated. So for this you have 0 plus 0 plus u1 1 and u3 1. So first approximation of u1 and first approximation of u3. So after substituting the value, you'll get 1875. So our first approximation for u2 was 0.25, and we got a new approximation as 0.1875. So this is for u2. Similarly, you need to calculate for u3 and u4. So u3, so the second approximation for u3 after calculation will be 0.4375, and for u4 it will be 0.4375. Okay, so this was for the second approximation. The number of times you repeat the steps, the more accurate answer you will reach up to. So again you will have to find the third approximation. Now if you observe, then u1 3, so this is u1. So for this, first you use the standard form. Now you will use the diagonal form. So you will just alternate the forms. First you will, for Jacobi method, first approximation, so second approximation by Jacobi method is by standard form, third is by diagonal, fourth will be by standard. So you will be just alternating the forms. So u1 of 3 will be equal to 1 upon 4, 0 plus 0 plus u2 of 2, the previous approximation, plus u4 of 2, that is the second approximation for u4. So this will be 0.15625. So if you observe, then u1 3 is nothing but u1 2 was 0.1875 and u1 3 was 0.1625. So similarly, u2 3 will be equal to 0.15625. Then u3 3 will be equal to 0.40625, and u4 3 will be equal to 0.40625. Okay, so see, our second, it was by standard form, this was by diagonal. Now we have to use again standard 5-point formula to calculate our next approximations of all the 4 u's, and then if you go on repeating it for n number of times, you will get answers more accurately. Like this you can have 6 to 7 approximation at least, it will be best, but you can have at least 6 approximation using this method, just alternating between standard and diagonal 5-point formula. So this was your Jacobi method, and if you observe in your notes, then you'll get values of u1, u2, u3, u4 by all the approximations, and they have taken up to 8th approximation. So final answer was 0.125976563. Then similarly it goes for all the rest of the numbers. So this were the approximations of u1, u2, u3, u4. So first we had considered the initial conditions for u1, u2, u3, u4 as 0, 0 and 1, 1 respectively, and we reached up to the final answers as 0.125976563 for u1, then 0.125976563 for u2, and 0.375976563 for u3 and u4 respectively. So they were the same. So these two were same, as we had taken the initial values as 0, so it was 0.125 something, and if we had taken u3 and u4 as 1, and we got the final solution, most approximate solution as 0.37 final. So you can take any initial conditions based on the surrounding conditions, and then you'll get the approximate solution by Gauss-Jacobi method. So in the next example, you are given a Poisson's equation, which is mentioned as del square u equals to 8x square y square. So first of all, you need to find the value of uij. So for this, del square u equals to 8x square y square, this is our given condition. Now the given equation, value of del square u we have already calculated, and it is ui plus 1 comma j minus 2 ui comma j plus ui minus 1 comma j upon its square plus u I comma j plus 1 minus 2 ui comma j plus ui j minus 1 upon h square. This is the value of u delta u square, first with respect to the ith component and then with respect to the jth component. So this is equal to 8, as it is given 8x square y square, so it is 8xi square yi square. So now solving this equation, we'll have, so you can have h square common. So from this you have ui plus 1 comma j minus 2 uij minus 2 uij minus 4 ui comma j plus ui minus 1 comma j plus ui comma j plus 1 plus ui j minus 1 equals to 8xi square yi square. So now keeping this 4 uij to the one side and rest of the thing to the other, we have, so 4 ui comma j equals to, now this ui plus comma j, ui plus 1 comma j plus ui minus 1 comma j plus ui comma j plus 1, and this plus ui comma j minus 1, and this minus 8xi square yi square. Okay, so upon h square, so we can multiply this h square to this side, so you can just write 8xi square yi square into h square. So now value of ui comma j is nothing but dividing this entire thing, ui plus 1 comma j plus ui minus 1 comma j plus ui comma j plus 1 plus ui comma j minus 1 upon 4 minus, now this 4 will cancel with this 8, so I'll get 2xi square yi square into its square. So now what we'll do is we'll just assume the values of this initial conditions, that is u1 u2 u3 u4 to be 0. So considering u1 0 equals to u2 0, which is equal to u3 0, which is equal to u4 0, which is equal to 0. Now we have to do now we need to calculate the first approximation of u1. So u1 1 is the first approximation, which is given by 1 upon 4 into, now as we have calculated this formula, we need to use this formula in this for the standard rule. So now as it is given ui plus 1 comma j, ui minus 1 comma j, ui comma j plus 1, and ui j minus 1. So if so you are considering this u1, right? So if you are considering this, then for this ui plus 1 comma j, so this coordinate will be nothing but, so ui is this ui plus 1 and j will be, so now by formula it is ui plus 1 comma j. So what is ui plus 1 comma j? So you need to consider, if this is u, then ui plus 1, so you need to go one coordinate further from I-axis, that is x-axis, and then j is nothing but j is simply j, so it is u2. So value of u2, so it is u2 of 0 plus, now ui minus 1 comma j. So if you consider ui minus 1 comma j, then you need to go backwards from u1. So it is, if you consider this, then you can directly write value of this, the value of u at this point is u equals to 0. So you can directly write over here 0, and then ui j plus 1. So ui j plus 1 is nothing but moving forward towards the z direction, so it is u30. So u30 plus ui and j minus 1, so you need to go backwards in this. So this is again value of u is 0, so minus 2 xi square yi square h square. So h is given as 1, right? So you can directly skip that, and x1 square and y1 square. So value of x1 y1 is nothing but, this is 0 initial point. When you move forward in this direction, these are the values of x1 x2 x3, and these are the values of y1 y2 y3. So after substituting, so x1 square will be nothing but 1 square, and x2 square is again 1 square. So initial condition for u2 was assumed to be 0. So you can directly write 1 upon 4 into 0 plus 0 plus 0 plus 0 minus 2. So this gives you minus 2. So value of u1 1, that is the first approximation for u1 is minus 2. Then first approximation for u2, which is equal to again same 1 upon 4. So where is u2? So this is your u2. So again you need to follow this coordinates. So ui plus 1 comma j, so you have to go in the right side following the x direction or ith direction. So this gives you 0 plus ui minus 1 comma j, so it is going towards backwards direction, and it was first initial condition, not the one which we have calculated. So you have to write here 0, because u1 of 0 was 0. Then ui minus I comma j plus 1, so you have to go towards the upper direction. So again this is 0, again 0, minus 2 into x square is again 1 square, xi square yi square. So xi yi is nothing but so if you consider, so as it is u2 1, you have to find the value of x2 and y1. So this is x2 y1 and x2 is nothing but this is x1, this is x2. So this is 2 square and y1 is nothing but u 0 is the initial, then this is y1, y2, y3. So it is 1. So square of this both, and this gives you minus 8. Similarly, you have to calculate for u3's first approximation. You have to follow the same condition. So again 0, 0, 0, 0 minus, then 2 into, again you have to follow 3, 1. So for this so xi yi, so if you consider u3 of 1 as this approximation, then this coordinate is nothing but, if you see, then this is the first coordinate. So xi value is this and xj is nothing but, yj is nothing but 2. So you have to write 1 square into 2 square, which gives you minus 8 again. So again similarly, if you consider for u4 1, then the value is 1 upon 4 into 0 plus 0 plus 0 plus 0 minus 2 into x square is 1 square xi y square. So if you observe, then so your u4 was nothing but somewhere over here. So u4 coordinates will be this coordinate and y coordinate will be this one, and this was 0, 1, 2, 3 and this was 1, 2, 3. So you can say that xi value is 2 and xj value is 2. So you can write 2 square into 2 square. So this will give you again, so u4 1, so minus 1, so it is minus 32. Now you need to have the second approximation for u1, u2, u3, u4. So for the second approximation, again you have to use the first approximation values. So u1 was here, right? So now if you consider u1 over here, then you first you have to use this. So now this was our graph. Now if you consider this, then u1, second approximation for u1, you have to follow again the same formula, but you need to update the values which you have got for u2, u3 and u4. So now value for this is nothing but 0 because we hadn't changed. So it is 0 plus 0. So value for both these values are 0. But now we have values for u2 1 and u3 1. So they are minus 8 and minus 8 respectively. So minus 2 into, again we need to follow the same procedure. So u1, so u1 for u1 it is x first, and for y this is first. So it is 1 square into 1 square. So this will give you minus 6. Then u2 2. For second approximation you have 1 upon 4 into 0 plus 0 minus 32 minus 6 minus 2 into, again u2. So if you observe u2, then it is I coordinate is 2 and y coordinate is 1. So it is 2 square into 1 square. So this is nothing but minus 17.5. And similarly u3 2 is nothing but 1 upon 4 0 plus 0 minus 6 minus 32 minus 2 1 square 2 square equals to minus 17.5. And last one is u4 2, it is minus 40.75. So these are the first two approximations. Similarly, you need to carry out more approximations using the same formula, and you have to get at least up to 3 to 4 numbers after decimal point accurate. So after certain stage, the values after, like for example, it is 12 minus 12.9912. So after one stage it will be minus 12.9978. So you need to stop at least after decimal point, you need to stop at least after two numbers after the decimal points are repeated, and the values for this will be u1 will be somewhat minus 13 because it is minus 12.99, so it is approaching towards minus 13. Similarly, u2 and u3 will be somewhat equal, and they will approach towards minus 22, and u4 will approach towards minus 43.